this video lesson we will learn a topic quadratic surds of class 10 syllabus. Now in order to learn this chapter you need to keep few points in mind. Now here, if you can find the square root of any number, then those numbers are said to be rational numbers. They are not surds. For example, root 4, the value of root 4 is 2, root 9 is 3, root 16 is 4. So they are rational numbers. But there are numbers such as root 5, root 3, whose square root cannot be determined easily, then we call such numbers as irrational numbers. Now, and these particular numbers are called surds. Now we have few terms. Now you need to keep these terms in mind. Pure surd. So if you have a single terms like this, the monomial with the root over, so these are pure surd. Similar surd. If this particular root over part is same, then these are called similar surds. And if the root over part is not same, then they are called dissimilar surd. Even though their coefficients are same, but they are dissimilar surds because their root over part is not same. And simple surd are these are the examples of simple surd. Mixed surd, here you got both rational and irrational number, mixed surd. And binomial surd means there are two terms connected by either plus or minus sign. Now conjugate. The conjugate of this binomial surd is 2 minus root 3. So in conjugate, their connecting sign will change. If this is plus, it will be minus. And here you saw that this is minus, so its conjugate will be root 5 plus root 3. Now we will learn the use of different operators like addition, subtraction, multiplication and division of surds. Now number 1 is your m root a plus n root a equal to root a is common, so you get m plus n. So if it is similar, 2 root 5 plus 3 root 5, you may add 2 plus 3, you get 5 root 5. These coefficients you need to add. But with dissimilar surd, this addition is not allowed. So 2 root 3 plus 3 root 2, these two are dissimilar because their surds are different, so it remains as it is. Now subtraction, m root a minus n root a. If root a is common, so you get m minus n. With similar surd, you got 3 root 5 minus root 5. Its coefficient is 1. 3 minus 1 is 2 root 5. But with a dissimilar, so it is 3 root 11 minus 2 root 5. So the surds are different, so this will remain as it is. Now multiplication. So multiplication can be done with both similar and dissimilar surd. So you can see here m root a into n root a, m into n. So when similar surd multiply, it will be free from this root over sign. Similar surd. So 3 root 2 into 5 root 2, 3 5s are 15. And now when similar surd will multiply, it will be free from the root over sign, because in this case 2 2s are, you get 4, and root over 4 is a rational number, so you get 2. Root over value of root 4 is 2, so 15 2s are 30. And dissimilar surd also we can multiply. So here you got coefficient as 1, 5 1s are 5, 7 3s are 21, root over 21. So when you multiply similar surd, it will be free from root over sign. Root a into root a is root a square, so this is equal to a. So if you write here 5, root 5 into root 5, 5 5s are root over 25, root over 25, its value is 5. Now the next is division. So you got m root a by n root a cancels, you get m by n. So similar, only similar surd can be divided. So 5 root 3 by 3 root 3, so root 3 cancels, you get 5 by 3. And root over 21 by 3. So here the short part is not same, but if you look at this 21, its factor is 7 into 3. So we can write this as root over 21 means root 7 into 3. So we can write as root 7 into root 3. So similar term, similar shorts we can cancel. So the result will be root over 7. Now from here you can see that only with similar short we can add, subtract and divide. Only with similar shorts you can add, subtract and divide, but multiplication can be done with any short, similar or as well as dissimilar. Now next we will learn about rationalization. Now if you got a fraction with root over in the denominator like this, you cannot leave this one as it is. So in order to get this denominator free from root over sign, so we follow the process of rationalization. So if it is a simple short, then with the same term you need to multiply and divide. So it will be a root over b by root b into root b, it will be b. So as I've already mentioned that when you multiply similar short, it will be free from the root over sign. So here you can see this is free from root over sign. For example, if I take this fraction 3 by root 7, now in order to make this denominator free from the sword, so we will multiply and divide by root 7, since there is root 7 here. So if you got root 5, so you need to multiply and divide by root 5. So this will be 3 into root 7. So these two will not multiply, rational and irrational, they will not multiply. So they will remain as it is. And root 7 into root 7, it will be 7. Now if you got somewhat like this, now here you can see in the denominator, now it is not a simple short, here you got a binomial short. So in order to rationalize, we use its conjugate. So if it is plus, its conjugate will, if it is minus, its conjugate will be plus. If it is plus, its conjugate will be minus. So terms will be same, but their connecting sign will be opposite. If it is plus, it will be minus. If it is minus, it will be plus. So now in order to rationalize this, now here you got minus, now we need to multiply by its conjugate, that is a plus root b by a plus root b. Now these two are same, so either you can multiply or you can since these two we find same, so we can write this as a plus root b square. Now this is coming in the form x square minus y square, which is x plus y into x minus y. So you can see this here, so we can replace this particular part by x square minus y square. So this will be a square minus root b square. So after we expand this, so we get, this is according to the formula a plus b whole square, that is a square plus twice ab plus b square, and square of a is square and square of root b will be b, and this is a square plus 2a into root b plus square of root b will be b. So here you get a square minus b in the denominator. Now this is free from root over in the denominator. You may have root over in the numerator, but in the denominator it should be free from root over. Now example of number 2 case. Now suppose you got somewhat like this, root 5 by 3 plus root 2. This is a binomial short. Now its conjugate will be 3 minus root 3 minus root 2, root 3 minus root 2. So we need to multiply both numerator and denominator by this. So when you multiply, this remains as it is. Now again this is in the form a plus b into a minus b, which is a square minus b square. Square of root 3 is 3, square of root 2 is 2, 3 minus 2 is 1. Now you may multiply. So this similar short also we can multiply. So 5 3 is a 15 and 5 2 is a 10. Only similar short we can add, subtract and divide, but this similar short we can multiply. So finally we get, after rationalization, we get root 15 minus root 10. So these are some of the properties that you need to keep in mind in order to solve questions based on this chapter.